2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome again to Mathline. Hey, it's a specialized segments day. I'm Ernie Roberts. I'm your host for this afternoon's session. And you say, well, what is specialized segments? What does that mean, Ernie? It means we don't get any call-ins today, but, they're big but, yeah, there we go. We're going to be able to take you through a topic, kind of like a tutorial, and let you get some paper, some pencil, maybe a calculator to do a little arithmetic with, and we're going to work some test prep. Did I say that right? Test prep. That's hard to say backwards and forwards. But anyway, we want you to sit back, relax, we'll do some math, and let's see what we're going to take care of today on test prep. Algebra apps for the Triangle Blockbusters. Can you read that twice? I sure can. Algebra apps for the Triangle Blockbusters. And some of you wonder, what in the world's a Triangle Blockbuster? Well, I'll tell you what. It goes back to what we've had in a couple of previous sessions. We've been talking about the Blockbuster and the son of Blockbuster. And my goodness, there are other members of this Blockbuster family. We say, well, why do you call it Blockbuster, Ernie? Because they are big deals. They're probably, if you were taking a first semester of geometry and a second semester of geometry, Blockbuster will be the biggest theorem that you have. You say, well, please tell us. If we haven't tuned in this week, we want to find out what is that Blockbuster. By the way, some of you may be tuning in on YouTube. We thank you. And also some of you may be checking us out on Passport. So there's lots of ways that you can catch this episode. If we move too fast for you, or maybe if we're moving too slow and you want to catch it at your own speed, you can do that too. So let's take a look at what is a Blockbuster in terms of geometry. Actually, AKA means also known as the Triangle Sum Theorem, all right? And the Triangle Sum Theorem, just to refresh your memory, is simply that the three angles, the inside angles now, of a triangle add up to 180 degrees, no matter what the look of the triangle is, whether it's isosceles, equilateral, scalene. Oh my goodness, what else can we have? Oh yeah, obtuse, acute, and right, equiangular, all those good things. All of those degrees inside the triangle will always add up to 180 degrees. That's Blockbuster. You say, well, why is that such a big deal, Ernie? Because I thought I learned that in 5th grade. Well, you did, and we actually proved it in one of our previous segments if you want to really know why it works. Whew, that was a mouthful, wasn't it? Now, let's talk about it just a second here. Why is it important? Because quadrilaterals build off that. Pentagons build off triangles. Hexagons get on through the polygons. They all build off the triangles. And many other things come back to work with us in those triangles. We start looking at right triangles and all the special things. So yes, Blockbuster is important. 180 degrees is where we start. And one more quick thing. I mentioned the other Blockbuster. How about it? The son of Blockbuster, which has got a little bit of Blockbuster in them. So let's check that out. We draw a little more line out through here. We pick up what we call the exterior angle. I'll call this angle 1, all right? And angle 1 takes us back to right there, okay? That's our angle 1. The measure of angle 1 is equal to, as we recall, the remote interior angles. That means the far away interior angles from angle 1 added together, the sum of those two angles. So how about it? We're going to say measure of B plus the measure of C, and I guarantee you, these two angles right there are always going to add up in degrees to the same degree measure in that exterior angle. And notice that exterior angle is supplementary to that angle there. That's not just any exterior angle, it's making a linear pair with that third angle. So when we look at those pieces, that's what we're going to practice today, all right? Now, as you know, we've been talking about test prep, whether it's state test, whether it is ACT, whether it's SAT, but these little guys are the geometry of it. These are the equations, and guess what? We said something about algebra apps today. We're going to apply some algebra and computation right back to these figures where they may not look exactly like the big blue triangle with the nice pretty angle out there, but hey, probably pretty close. So let's move forward on this. Let me move this one out of the way, and we shall move to our first slate of problem here. All right, let's take a look at it here. Solving for x and y. Oh, here we go. Already algebra apps, aren't we? I put some numbers here for us. There's 70 degrees. There's 70, 50, and 50. Now, that's kind of nice that I gave some numbers that got repeated there. I also gave you nice numbers that end with zeros, because this will make things work a little bit better. By the way, this is not 24. That's supposed to be 2y, okay? Now it looks a little more like 2y. Now we got 3x minus 1 down here in this little guy's angle, and the basic idea is let's figure out what x and y will be in these situations, all right? Now, take a look here. Let's talk about x. We'll just talk about x first. Because notice y connects over here in another triangle, and you know what? We need to know a little bit about what is that angle right there going to be worth, all right? Maybe we know what angle here is going to be worth, because that will lead us to that one over there. Oh my goodness, there's so many connections, and this problem, you're going to love it. Now, what do? Remember how many degrees are in a triangle? Any triangle, we got 180. We've used up 50 and 50. Look on the right of my page here, everybody with me now? You got it? That's 100 degrees already taken care of. So in my mind, I'm thinking, I've got 80 degrees left over. So to find this value of x, we're going to take 3x minus 1, and we're going to let it equal that missing 80 degrees. Now, I'm going to tell you something. If you know automatically there's 180 degrees in that triangle, it's very quick to get to that point. And you start thinking, okay, we've got a minus 1. What do we do with it? It's simple pre-algebra at this time, right? We remember, yes we do, we all remember. We're going to add 1 to both sides of this thing because it's a balancing effect. We move it off one side, we've got to do the same thing to the other. So we're adding to both sides, the addition property of equality. That gives me 81 over here, which is kind of nice. It's going to be even nicer when I put a 3x down here by itself because I know 3 will divide into 81 evenly. How many times will it go? Well, for those of you who aren't sure, some of you are already saying, I'm going to go with my crusty calculator. I'm going to do that too. Let's go to our calculator here. All right, guys? 81, we'll divide it by 3. And it goes 27 times. And that's what x is equal to. X equals, what did you say? 27, right? Now, let's take one more look at this. Now, I have half the battle won. I really do. Now, my friends, let's look at something going on here. If you'll see 70 and 70 right there, this is where you start noticing some things that may be thrown in there that can help you. We have now how many degrees? What did we say? We had, oh goodness, what was it? 80, right, for this angle right here. So I'm going to put a little 80 right there. So we've got 80 and 70. And you know what we've got here? We've got a nice little straight angle effect here. So how many degrees have we got in this little piece right here? Aha! Did I say you add up to 180? That's the beauty of 180 is everywhere in geometry, isn't it? But add the, first of all, 70 and 80, get 150. Subtract from 180, and that's some mental math we're doing, I know. But when you take these tests, you got to have some mental math, especially on the ACTs and SATs, because they're time, my friends. You don't have time to waste in punching the calculator for little things. So let's see. I got a 30 right there, 30 degrees, which tells me, aha, I've got 80 degrees left over again. We say, well, Ernie, we had 80 over here. We had 80 over here. Why not? 2y will equal to 80. This one is really easy. We do not need calculator for this one. Divide both sides by 2. And we have y equaling to 40. Now, I'm going to give you another quick little moment here. You say, did we need to go through all this finding out 30? Not really. Because notice, we had a 70 and a 70 here. No, if you look closely, remember I said there's going to be something about those 70s. Here we go. Zig, zag, the Z. I like to call it, there's a Z. It's on the side. I know you can just turn your TV set around, right? But let's see here. What that tells me is we have parallels. Because those alternate interior angles, see how they are? They're congruent, which means the lines are going parallel. And you say, well, what good is that? Well, that tells me also that I have corresponding angles. See that 3x minus 1 and that 2y? They're corresponding angles, and since those lines are parallel, they're congruent. So once I figured I have 80 degrees left here, it was easy to get to x, right? 27, by the way, it does check. And when we look back this way, we have 40 times 2. Well, that's got to be 80 also because they are congruent. Corresponding angles when the lines are parallel are congruent. However, you can't assume they don't just look that way. You've got to have some real proof. Congruent angles. So if alternate interior angles are congruent, then the lines are parallel. Sounds almost like we used in another theorem setting here. We started with parallels going to alternate interiors. That's why I'm very, very picky about when you name reasons, what comes first. This time, the angles came first to give you the parallels. Then, you used your parallels to get to the corresponding. Cool problem. Really good thought process and a good type ACT, SAT, and EOC test review question. All right, so there you got it. A little bit of fun there. Let's take one without a picture, all right? Oh boy, we always wonder about that. We know we have a triangle, ABC, and according to this, we got some information. We have angle A equaling to 2 times angle B. Whew, that's a mouthful. Then we got angle C that's going to be worth 3 times, wow, angle B. So let's see here. I got an A, a B, and a C. And then we know what? Blockbuster, Triangle Sum Theorem, however you want to call it, adds up to 180 degrees, right? All those interior angles. So I know I've got a 180 coming in here somewhere. What I've got to do is figure out what's going on here. How do I set this up? Because I see A and I see B in 2 places. So you know what that's going to do? I'm going to say, let's let the measure of angle B, we're just going to make it easy on ourselves. Make it X, all right? Which means the measure of angle A, 2 times that. Well, that's 2x, isn't it? And then last but not least, we got measure of angle C, rocking in at 3 times x. So see, it was nice because B is involved in both of those, so we can call it the same thing. Now, why did you say, Ernie, why did you change them to x's? Well, for a simple reason. All these m's and b's and stuff, they can get you distracted. And plus, then you've got angles popping up here. Let's just go for the measures being x, 2x, and 3x. And what are we going to do? You got it. We're going to add to get, how much? 180. So we got x, we got 2x, we got 3x, we add them, we get 180. Well, remember, that's like 1 in front here. Don't write 5x. We'll be in trouble. All right? This is going to be a 6x altogether. 6x equaling to 180. Easy, easy division. And by the way, making a little note on this, a lot of you depend on your calculator and say, well, if I don't have my calculator, I can't get through these tests. The ACT, the SAT, and your end-of-course test are pretty much designed to be able to go without a calculator. Certainly it helps. Certainly it's good that you have them. But these questions are usually designed such that you can work them, get to the final answer without a calculator to assist you. If you need it, use it. But again, this is where we are. Now, are we done? Are we done? No, we're not done. Because what does it say? What does it say? It says we're going to find the measure of each angle. So how many do we have? We got 30 right here. We got a 60 right here. And then we have a 90 right there. Now you say, well, Ernie, are they going to ask us all 3 of those? They may not. They probably won't. Probably ask you what's the largest angle, perhaps. What is the smallest angle? Perhaps what kind of triangle is it? You say, well, what do you know? How do you know that? 90 degrees. It's a right triangle. So lots of variations can come from this setup right here. But knowing Blockbuster, knowing 180 degrees in a triangle, knowing the Triangle Sum Theorem, you're in business. You're in business. You can get through that. So that's a little bit of practice there, a little bit of algebra application. So let's see what else we can dig up here. Let's go back and take a look at a triangle with all sorts of crazy looking angles. Oh my goodness, look at that. I ran out of numbers almost, ran out of my fingers. Got 10 angles in there. Plus we had 2 that I actually gave you numbers on, okay? So we gave 60 down here in this corner, 140 over here. And what we want to do is figure out how to find each angle. Now, I tell you, a lot of times, you're not going to have to find all 10 angles on an ACT, an SAT, or an end-of-course test. But any one of these could be an option to figure out, all right? And I'll be honest with you, it's probably going to be one of these 4 up here they would ask you to figure out, because you have to work through these little guys, 2 and, what is that one? 2 and 6, yeah, to get up there to 7, all right? Or perhaps you might, well, in this case, that's what we do. We need to know about what 2 and 6 are, don't we? If we can do that, it's easy to find 7. Then it's easy to find everybody else because, well, let's see why. Let's see why. First of all, let's go down here to angle 1, since it's the first thing we're looking for that. We know the measure of 1, linear pair means we have supplementary angles. So when we look at 1 and 60 and add it up to 180, do a quick subtraction. That's exactly where we go. We have 120 degrees. Life is good. While we're at it, let's talk about angle 2. Some of you go like, well, if we were looking for angle 7, I guess we didn't need to. But say, that's what I said, look at each angle. We want to go through the process, see how would we find every angle in this picture. 2 is lying vertical from 60, all right? And when we know about vertical angles, They're formed by two intersecting lines. That's right. So here we go. Got two lines intersecting beautifully. And they lie opposite of each other. And by lying opposite each other, they're going to be congruent. So 60 degrees pops right in there. They look congruent, but it looks like this really isn't hack it. We need to identify them. They are vertical angles, and there's a nice theorem that says they're congruent. Not quite as Blockbuster, but a big one nonetheless. It'll help you out of a lot of jams. Speaking of vertical angles, how about it? 1 and 3. Some of you say, well, don't we have linear pairs? Oh, we got all sorts of things around that point, don't we? We do have 2 and 3 that are linear pairs, but 1 and 3 vertical. And you know what? It means they're congruent. So here we go. Angle 3 we now have at 120 degrees. Now what's important here to help us get up here eventually is that I know there's 60 degrees hanging right there. That's going to help me. It's going to help me a lot. So I need to know that number. Let's work down here. Angle 4. Linear pair once again. So measure of angle 4. How about it? We're going to let it go at 40. Angle 5, vertical to 140. You see how quick this is? Everybody's going, I've already finished this, Ernie. You're just slow. Well, I'm going to make sure. I want to make sure everybody's with us. Now, I've got 5 and 6. I'm getting linear pairs, or we can look vertical angles. I'm going to go with angle 6 equaling 40. So all of a sudden, things begin to pop up very nicely. And oh, by the way, we've got a 40 going here. 40 and 60, 100. You think I'm stuck on 100 degrees? Well, I like those numbers, don't I? So what's going to happen here is we've got 100 degrees inside our triangle. Let's go up to 7. And our good old friend, the Blockbuster, says 180 degrees in that triangle. So let's pop it up there. We've got 80 going there. Is that right, folks? Yep, 40 and 60, 100. 80 left over. Now let's pick up angle 8 and 9 and, of course, 10. 8 is supplementary to angle 7. I go with 100 there. And let's talk about angle 9. Looks like it's vertical to 7. And that would be, my goodness, what would that be? That would make it 80. And then last but not least, you got angle 10. And angle 10 looks like you're back to 100 degrees. Now, quick point, and I'm going to make one here. Angle 10 is an exterior angle of the triangle. Remember that? Blockbuster, son of Blockbuster. Oh, yeah. So if I knew 60 and 40, remember that should add up to those two together. That's the son of Blockbuster, or the exterior angle theorem, as we like to call it in geometry. Goodness, that's 60 plus, that's 100. Well, it's the same thing, isn't it? So you've got lots of ways to get out of this when you start working with it. If you spot things, more power to you. If you can back up what you're spotting, you say, hey, that's a Triangle Sum Theorem. Oh, that's a Exterior Angle Theorem. Oh, that's something else. And you have a valid, legit reason, theorem, rule, some sort of thing to back you up, go for it. You'll probably be where you're going to be, and you hopefully will get there pretty quickly, all right? So that gives you a little bit of a feel for those. Let's do some real algebra, all right? We got a couple of more time for show here. So let's take a look at this. And all of a sudden, Ernie has made it not as easy to find all the angle measurements. You say, why'd you do that, Ernie? Well, you know, they don't always make it easy for you come test time, do they? Yeah, I know that's for sure. So let's talk about it. Oh, remember I said something about son of Blockbuster, exterior angle theorem? Right there it is. That's an exterior angle. Is equal to what? The sum of the remote interior angles. How do I know they're remote? Because they're far away from him. Her, however you want to call this angle, all right? So, yeah, that'd be a good idea. So how about it? Let's go with 6x minus 7. There's our exterior angle, equals the sum of these remote interiors. Now that is, in case y'all were wondering, it's 103 minus x. So now you can get ahead of me again, right? Let's add 2x, because that's what that measurement is, 2x degrees. Those little notches there are degrees. And let's do some algebra. And you say, wow, this doesn't look so bad. It really does. It really doesn't, does it? So let's put it together. And by the way, when they give you algebra to do on a ACT or SAT type test, they're not going to try to make crazy answers. Usually they're going to make things come out pretty nice and even because they want to know that you can work through the process. The arithmetic comes in maybe another question or something there, all right? So let's piece these things together. This looks pretty easy. We got 6x minus 7 equaling 103. And we're going to put minus 1 plus 2. Those are the x's. They're like terms. So we got a plus x going. Now let's move things around. Let's move that x here to this side. And my goodness, what have we got? We got 5x minus 7 equaling, it looks like 103. All right. Add the 7. We're doing a lot of adding here. Well, there we're going to do it here. By the way, that was subtraction property of equality when we subtracted the x from both sides. Here we're going to do the addition property of equality. And in just a minute, we're going to probably divide. How about that? That's just the way it works, isn't it, with these lovely, lovely equations and such. So let's see. You got 5x equaling to, it looks like 110. Divide out. Let's see what we got. Take that bottom out for me, guys, if you will. Thank you. And we put a divide by 5 both sides. We have x equaling to 22. Now that might be what the question asked for. This one I said, let's find the angle measurements, all right? So let's put our 22 right in here. Goodness, you say, what does that give us? Calculator will tell you, but also your brain will. That's 132 minus 7, so that gives us 125 degrees right there for the big exterior angle. Now I'm going to put another little angle right here that we didn't cover. But guess what? It should be 55 because we're linear pairing here, right? These two add up. So see, you might have to find all these x's, and it comes back and says, what's that angle there? What's that angle right there that doesn't have anything on it? You gotta go, wow. There you go. Figure out. The next one up here, the top angle, how about it? 103 minus 22. Those are some of those where it makes my heart kind of beat a little bit. Let's see. Want to do it on the calculator? Some of you are saying, no, I'm going to do the calculator. Well, let's do the calculator just for you guys. Actually, I believe it's going to give us 81, but let's find out. It is 81. That one really wasn't as bad as we thought it was going to be, right? And last but not least, how about it? 2 times 22, we should get 44 degrees. That one you can do without a calculator. Let's add them up together. Make sure we do have 180. That's going to give us, my goodness, there's that one. Almost 100, it's a 99. Add that to 81, you are back to 180. So there you go. That's an example. A little bit of algebra goes a long way working with that exterior angle theorem. Let's do one more for practice here, all right? Let's see what I've got here. I've got 4x plus 6 right out there. That looks like the same figure, doesn't it? And we're going to use 2x plus 4 right here. They're degrees. And we've got x plus 24, again, degrees down there in the corner. So again, I can't add 3 angles and make 180. I want everybody to remember that, all right? Sometimes you've got to look and say, wow, there's got to be a connection here, here, and here. There certainly is. So remember, the connection is that the exterior angle, that's this little guy, 4x plus 6, equals the sum of the 2 remote interior angles. So here we go, 2x plus 4 plus x plus 24. Whew. And again, some of you say, well, that looks like this could be some heavy algebra. When you put the like terms together, these fall out very nicely. Remember, that's like 2 plus 1. That's going to give me 3x. 4 plus 24. Mental math again. How about it? 28. We're good. Everybody looking good out there? Of course you are. You're on TV, and I can see you. We got 4x plus 6. Let's move things around. Subtract the 3x. I get an x plus 28. On the left-hand side, I got to do the same thing. Got to subtract the 3x, right? Whoops, what did we do here? We did not get x plus 28. We just have 28. Don't make careless mistakes, folks. All right, now from here we got x plus 6, jumping the gun a little bit. Still a positive 28, I'll say that though. Now let's remove this 6. And you know what? I'm going to get x equals 22. Well, that's the same answer we had last time. Don't get excited. It's not going to be 22 every time. It just so happened these two problems worked out the same way. Now, let's see what the degrees are. I bet they'll be a little bit different this time. I hope they are. Let's put that 22 right in here. We'll get a 46. Y'all see that? 22 plus 24, 46. Put our 2 times 40, oh, that's goodness. 2 times 22, that'll give us 44. I was jumping a gun again. Get a 48 out of that. That one looks a little bit like it might just been not drawn so much to scale, but you know what? You can't count them down on the test either. And last but not least, let's put it out here. Let's see, we've got 4 times, that's 80. 88 plus 6 looks like 94. My question is 46 and 48 going to add up to that? Yes, it will give us 94. And you know what? We need one more angle. One more angle. We got it? Can we find it? Subtract it. 180 minus that. What do you think? 86 degrees? I like 86 degrees. And my goodness, it solves the triangle. It also satisfies this linear pair. So x equals 22. Our angles are 48, 94, 86, 46. And once again, you have no idea which angle they're going to ask you for. All right? They probably won't ask you for all four of them, but you're ready to find any one of the matching pairs there, or even one or two or three, or whatever you need. All right? So you can even say, what's the largest angle of the triangle? 86. Hey, thanks for tuning in this afternoon, or anytime you're on with us on YouTube. Remember, Mathline Online is where you want to go. And again, thanks for being with us, and we will see you again next time.